Hi, I'm Joshua Lee, and in today's video we will be taking a break from electricity and learn about chemistry. We will be learning about the periodic table of elements. Most of you have probably heard of the periodic table and roughly know what it looks like, but why is it so significant? Let's start about learning about the creation of the periodic table. The periodic table was first developed by a man named Dmitri Mendeleev in the 1860s. During this time, only about 60 elements were known to humans. We also had a pretty good idea about their atomic weights. So the most logical way of ordering the elements would be to order them by their weights. But Mendeleev realized that some elements were very similar and had a close relationship. He noticed that certain traits repeated every 7 elements. This is a side note. We now know that it repeats every 8 elements, but back then elements were identified based on their reactivity, so the noble gases which don't react were not identified yet. So Mendeleev organized these elements by this repetition. As the repetition went on though, it became less and less clear. Many scientists just assumed that that's how it was, but Mendeleev continuously worked and figured out that his idea wasn't wrong. It was just that some elements simply hadn't been discovered yet. So Mendeleev was able to make blank spaces on his table for elements that were undiscovered. Mendeleev is considered a genius because he deeply understood how elements behaved. He could predict the characteristics of an element just by where it was located on the periodic table. One of these elements he predicted was gallium. At the time he named it Eka aluminium because it was one space below aluminium. Eka being Sanskrit for one. When Mendeleev first predicted the existence of Eka aluminium, no sample of it had ever been discovered. Yet Mendeleev was able to figure out what it would be like just by its position on the periodic table. He predicted that it would have an atomic weight of 68, be a solid metal at room temperature when completely isolated, and have a shiny surface, conduct heat very well, be malleable, and have a low melting point. He even predicted that a cubic centimeter of it would weigh 6 grams. A few years later, a French guy discovered this element. He named it gallium after Gaul, which was the historical name for France. It was one space below aluminium, so it was Eka aluminium. So were Mendeleev's predictions correct? Gallium's atomic weight is 69.72. It is a solid metal at room temperature and it melts at a meager 30 degrees Celsius, so it melts in your hand. A cubic centimeter also weighs 5.9 grams, so Mendeleev's predictions were very accurate. Mendeleev argued that he actually discovered gallium before the French guy in his mind. He was also so certain of his predictions that when his predictions didn't match with the French guy's data, he published papers saying that the French guy's data was wrong. The crazy part is Mendeleev was actually right. The French guy's data was wrong. Mendeleev, never having examined an actual sample of an element, knew more about it than the French guy did. Not only did Mendeleev predict gallium, he also predicted scandium, germanium, rhenium, and technetium. In fact, technetium was so rare it couldn't be completely isolated until it was synthesized in a cyclotron in 1937, which was about 70 years after Mendeleev predicted its existence. The groups of elements that Mendeleev studied were actually pretty similar to the groups we study today. Over here, we have the alkali metals. Alkali metals are shiny, malleable, ductile, and very good conductors. They are very reactive because they only have one valence electron, meaning that they try to give away the extra electron so they can have a full valence shell. Alkali metals often react violently when they meet water. Since they are so reactive, they aren't very common in nature. Instead, scientists have to extract them from other compounds containing them. These elements here are the alkaline earth metals. These elements have 2 valence electrons, so they aren't as reactive as the alkali metals, but still pretty reactive. When alkaline earth metals meet water, they have similar reactions as the alkali metals, but a little slower and release less heat. This large section here, this rectangle, is made up of transition metals. These are the metals you think of as metals. So gold, copper, iron, silver are all transition metals. This group is fairly unreactive, and they often have high melting points and are good conductors of heat and electricity. Being metals, they are also very malleable. Skipping over to this section, these are the halogens. The halogens are also very reactive since they just need one more electron to complete their outer valence shell. So they react very well with the alkali metals that try to lose one atom. This reaction is actually the one that creates our table salt. As you probably know, table salt is NaCl or sodium chloride. So it is the product of sodium, which is an alkali metal, and chlorine, which is a halogen. Here in this rectangle, including hydrogen, is a mix of gases, metals, semimetals, also known as metalloids, and nonmetals. This group is also generally unreactive. Semimetals are pretty interesting to me because they have some properties of metals and some properties of nonmetals. So semimetals, mainly silicon and germanium, are used to make semiconductors for electrical circuits. Generally, a lot of the elements here are studied in organic chemistry. Down here, we have the lanthanides and actinides that actually belong here. The top row are the lanthanides and the bottom row are the actinides. These elements were mostly undiscovered during Mendeleev's time because they are all so similar to each other, making it almost impossible to distinguish them from one another. Lanthanides are very reactive and tarnish when exposed to air. They have very high melting points. The actinides are radioactive elements and very dense. All the way on the right side here, we have the noble gases, also undiscovered during Mendeleev's time. They are called the noble gases because they don't react with other elements since they have full valence shells. They have low boiling points and are all gases at room temperature. Mendeleev died without receiving a Nobel Prize, but he did receive a greater honor. In 1955, scientists at UC Berkeley discovered 17 atoms of a previously undiscovered element. In 1963, it was officially named Mendeleevium after Dmitri Mendeleev. In today's video, we learned about the periodic table and why it's so important. I hope you enjoyed this video. Please subscribe and thanks for watching.